I recently joined Hotels.com, although of course I've been in Java for a long time. The guy up there in the corner is a Hotels.com icon. It's Captain Obvious, because Hotels.com is the obvious choice. So if you want to go on holiday, try Hotels.com. Okay, so let's get into the real bit. And the thing I need to emphasize really importantly is that there's always a bottleneck, because you get a lot of people that come and say, we've got a bottleneck, we need to fix it. But that's not the case, because there has to always be a bottleneck. Otherwise it takes no time at all. It has to be doing something, that's the bottleneck at the time. So what you need to do is have a target. And you need to know that if your system is not reaching, if your application is not achieving the targets, then you need to look for the bottleneck and fix that. So it's an important thing. Don't just say, I've got a bottleneck, I need to fix it. You need to have a target. So, over the years, there's been quite a lot of surveys of the common problems that developers see. And this is the list roughly in order of the amount of problems they've seen. So the most common, resource leaks, slow DB queries. The least common is memory churn. But even down at the bottom end, there's a response of about 7 or 8% of applications see that. And up at the top end, it's on like 50 to 60%. I gave another talk. You can find it very easily. Just look for Shirazi and 10,000. You don't need to have seen that talk for this talk, but if you want to get a more detailed view of performance and memory tuning, I recommend watching it. So I'm going to split up these most common problems into a variety of types. And I'm going to do them in this order, so configuration, and then the DB types, and then inefficient code, and then the memory and resource types. We won't have time to go beyond that, and the reality is that GC pauses will take me a couple of hours, so we haven't got the time, and concurrency would take an entire day to analyze. So I can analyze most of the ones that we've got here, not everything. Configuration issues is something like 20% of production problems are just down to configuration issues. So it's kind of important. And there's a really good tool for this. It's called diff, right? You've all used it. And it's not a joke. Most of the problems that you see related to configuration, about half the configuration-related issues can be solved just by diffing the old config and the new config, and manually looking through there and saying, okay, actually, this shouldn't be making that difference. And it's a discipline. So this isn't specific to Java, it's every type of deployment, and it's a discipline issue. You need to have the discipline to have all of your config in a format where you can see all the config of the current system, all the config of the expected deployed system, and be able to diff the two in an easy way, using whatever diff tool you prefer. They all work. So you need to gain the discipline to do that, and you'll eliminate 10% of your production problems straight away just doing that. That's config, nice and straightforward. Okay, so now we're going to move on to data store issues. And there's 3 different sections in the most common problem. There's individual queries that are slow. There's where you're creating too many queries and you should be able to combine those. And there's a slow database, which is just basically an overloaded database. And on the data store side, I use data store for the generic type, including NoSQL, NSQL. On the data store side, there's always lots of tools that provide you to analyze them. Obviously, I can't go into that because there's 1,000 products, well, several hundred anyway. But there are things that always matter. Okay, the indexes always matter. If you want to have an efficient query, you need an index on the fields that you're querying against. Caching in memory always makes it faster. If you can cache everything in memory, then you don't need the faster disks, but typically you need the faster disks. And actually the most important thing is the schema. And people get this the wrong way around a lot. They think, what's the schema I need? And they put together a schema, and then later on they think about the queries. That's the wrong way round. You have to think about the queries that you're going to make against your data store, and that should define your schema, because the schema is the biggest bottleneck in terms of how your queries can perform. So always work it the other way around. To decide on the queries that the types of queries that you're going to need to perform against the data store, and then decide your schema based on that. So on the Java side, any type of external data store request is always going to be more costly than a log entry. So you should always just log them. And pretty much every data store communication layer has a logging capability that you can use. So you should do that. And the things you want to look for: individual queries that take a long time, multiple queries that are identical, or that are different only in a parameter. All of these things can be improved. And you should try and have a baseline. You should always try and have a baseline for anything you've got, because that makes it much easier to compare. And this is like a critical point. If you've got connection pools, you absolutely have to monitor the waiting time to acquire the connection from the pool. So you've got a pool of, so let's say 50 connections. If you're only using 10 of them, it should be instantaneous to get another connection from the pool. If all 50 are in use, then the thread has to wait to get the next connection. And that's something that you need to be monitoring. You need to log that. So you need to know that either I have to change the pool size, or I have to be aware that we're going to have delays. We've got a limit to the throughput that we can do. Okay, so I'm going to do a little digression now, and I'm going to just talk about wrapping interfaces. I know some developers who can't stand interfaces, but there's a good reason for using them. So this is just a simple one, say 2 methods. And this is an implementation. It just prints hello, goodbye. There's a little pause, a half a second, an 800 millisecond pause. And then this is a say wrapper. And the wrapper wraps any implementation of say. So all this is basic 101 Java, really straightforward. But the point is that if you've got things that are developed using interfaces, it's transparent to be able to wrap them. Okay, so I can flick over and run this code here. Actually, it's already run, but I'll run it again. And there we go. The wrapper code, as you can see, it looks straightforward. Sorry, let me just make that a bit bigger. Really straightforward. And the second set of code, you've got no idea that you'll say is a wrapper. It's all transparent. So the reason I did that quick run through is because the JDBC API is completely or almost entirely implemented with interfaces. So it's the perfect candidate for you to be able to put in a transparent logging layer, just wrap the API. And you can do it yourself, you can roll your own very easily, but in fact, there are quite a few products that will do it, that have already done it, and you can just insert it into your system in a very transparent way. I use P6Spy. You get log lines into a separate log. Looks like this. The top there is the example, the names of the fields, and you've got a timestamp, the execution time, the statement. It's very easily processed. Whatever your line processing tool that you prefer easily handles that. And the things you want to look for, obviously, individual times that are beyond the threshold. Queries shouldn't take a huge amount of time. And when you've got too many DB queries, typically it's because you've got a piece of application code that instead of doing one efficient query and handling the result set, it's actually just repeatedly doing queries in a loop. So you can easily see those also. Just look for, it's a bit more difficult to process that, but look for things using the same connection where a lot of the queries are happening very close together in time. And then the slow DB, it's an overloaded DB, that's just going to cause a lot of your queries to just take a long time. So instead of individual thresholds, you get some simple queries that are just going to take a long time. So you can see all of these problems very simply from this kind of a logging layer. And really there's no overhead compared to the requests, the cost of the requests. So you really should have that in your system. Okay, so something slightly more interesting, I hope. Inefficient application code, and that's anything that's taking too long. So obviously you're going to need to profile your system to find out exactly what the bottleneck is in this situation. And it's important to understand that there's two types of profiling. There's sampling and there's instrumented code. So the sampling just takes, it's a stack trace essentially, every n milliseconds, and it looks at that stack and determines where the hot spots, the hot parts of the code are. And the instrumentation type of profiler, it manipulates the bytecode to wrap basically every method, just like that interface wrapper, but it does it at the bytecode level. Wraps every single method, and it can take an elapsed time of every one of those methods. Now the thing is that the good development practice are that you write lots of small methods, not big chunky ones, which means that you're going to be wrapping lots and lots and lots and lots of methods, and that's going to have a very high overhead. So typically, you always want to use the sampling code. Unless you know exactly what you're doing, you want to use the sampling profiler when you're execution profiling. Okay, so that's it. I'll take any questions if you have. Excellent, I've saturated your minds. So, time for a break.